Hi, my name is Lynn Heron, and today we will be learning about the mole map. So, in this map, we will have four main circles to represent different units. The first we will have is mole. The second will be mass. The third will be number of particles. And the fourth will be ideal gas. So the point of this diagram is to show how to transfer back and forth between these units. To go from moles to mass, and from mass back to moles, we will use a bridge number. The bridge number for this will be the molar mass in grams per mole. To go from moles to number of particles and back, we will use Avogadro's number, which is 6.02 times 10 to the 23rd. Finally, the transfer from ideal gas to moles and vice versa will be 22.4 liters per mole. And the way in which we will use this is as follows. To go from moles to mass, we'll multiply by molar mass, and to go back, we'll divide. So this goes for, from moles to number of particles and for the ideal gas. You will always multiply going out and divide going back in. So say we have C2H3, Cl3O2, and we're going to find the molar mass. So as we know, the molar mass is the mass of a given chemical element or chemical compound divided by the amount of the substance. And this is found by adding the standard atomic masses in grams per mole of the constituent atoms that are part of the compound. So the molar mass of C2H3Cl2O2 can be found by first finding the molar mass of C2, which will be the mass of C, which is 12.01, times 2, which is the number of moles, and that equals 24.02. And we're going to do this for H as well. The mass of H being 1.01, we'll multiply that by 3 because there's 3 moles of it, and that'll be 3.03. For Cl, we'll use 35.45, multiply that by 3, because there's 3 moles, and we'll get 106.35. And finally O2, which will be 16 times, should be times 2, which will give us 32. And so the molar mass is going to be 165.4 grams per mole. So now that we know the molar mass of this, we are going to, I'm going to give you 500 grams, say, and we're going to try and find the number of moles. So if you remember from the mole map, to do this we're going from mass to moles. And when we do that, we will be dividing. And we'll divide by the molar mass. So we'll do 500 grams divided by 165.4, which is the molar mass, and that will give us the number of moles, which in this case will be 3.023 moles. Okay, and we're going to try another problem with the same equation, or compound, and this time we're going to find the grams. And I've given you the moles here to start with. So we're going from moles to grams, which means we will be multiplying. So we're going to start by taking the number of moles, we're going to multiply it by the molar mass, and that will give us grams, which is 3.3 grams. And so basically this is just a quick rundown of how you can use this mole map to go back and forth. So in summary, we have the entirety of the mole map here, showing how to go back and forth. Going out is multiplying, going back in is dividing, and it's always like that. Using molar mass, Avogadro's number, or the 22.4 liters per mole preset to go back and forth between these. So, just a summary, the way to find molar mass is by adding the standard atomic masses in grams per mole of the constituent atoms.